Hey, what's going on, guys? Let's do this problem right here. This question is asking what is the third Maclaurin polynomial for f of x is equal to 1 over 5x plus 1. Let's see how we can do this. So this is similar to Taylor polynomial. If you have done Taylor polynomial, you know that you replace x value with a values and you find the final answer, right? Here same thing, but instead of instead of x values, we are always going to have 0. So that's the only difference between Maclaurin and Taylor polynomial. And let's go ahead and expand this one. First of all, we have to notice that they are asking for third Maclaurin polynomial, right? Third means we have to look at 3 derivatives. So we have to look until f triple prime, right? So we have to expand this equation until f triple prime. Now let's go ahead and do this. First we are going to have f of 0, then plus f prime 0 over 1 factorial times x power 1 plus f double prime 0 over 2 factorial times x square plus f triple prime 0 over 3 factorial times x cube. So this is the generic equation. Now we have to find the derivatives. So first of all, f of x is going to be this one. F of x is equal to 1 over 5x plus 1. So let's write this one right here. So this is going to be f of x is equal to 1 over 5x plus 1. You can also write this one as 5x plus 1 power minus 1, right? Same thing. Now we have to find 3 derivatives of this. So let's start with the first derivative. If I take the first derivative, the minus 1 is going to come to the front. So this is going to come to the front. So this is going to be minus 1 times 5x plus 1. And this is a chain rule, right? Whenever we have bracket and terms like this is going to be chain rule. And inside derivative is going to be 5, right? We have 5x, and if you take the derivative of that one, that's going to be 5. So this is going to multiply by 5. So we are going to have minus 5 times 5x plus 1. So this is our first derivative. Now let's go ahead and do the second derivative. And also we are going to have power minus 2, right? We have to subtract one more power to this. So we are going to have power minus 2. Now if I take the double prime x, now this minus 2 comes to the front and multiply with this one. That's going to give us plus 10. And then we are going to have 5x plus 1 power minus 3, and inside derivatives again is going to be 5. And we can also bring this 5 to the front. That's going to be 50 times 5x plus 1 power minus 3, right? Now let's go ahead and find the third derivative. So this is second derivative. Third derivative is going to be this. We have to take the derivative of this one. This is going to be minus 3 times 150. That's going to be negative 150 times 5x plus 1 power minus 4 times inside derivative, that is 5. And if you multiply 5 by 150, that's going to give you negative 750. And then we are going to have 5x plus 1 power minus 4. Now all we have to do is we have to plug 0 instead of x values. So let's write this one instead of f of x, f of 0. So f of 0, f of 0. Now all we have to do is instead of f, we have to plug 0. Now let's start with the first one. If you plug 0 for this one, this is going to become 0. 5 times 0, that's going to be 0. Plus 1 power minus 1, 1 over 1, that's going to be 1. So f of x is going to be 1. And if you notice, everything is going to be, if you plug 0 for this one, this will become 0, and this one remaining 1 power minus 2. If you take 1 power anything, it's going to be 1, right? It doesn't matter minus 3 plus 3 or anything, you will get always 1, because 1 power minus 3 is basically 1 over 1 cube. You are still going to get 1. So you can notice all the inside bracket value is going to be 1. So all we have to do is just take the outside values, and that's going to be the values we are going to apply. And if you take the f prime 0. So this is f0, right? Instead of writing x, we write f0. So f prime 0 is again, it's just going to be minus 5. And then f double prime 0 is going to be just 50. And f triple prime 0 is going to be just negative 750. Right, so this is our derivatives. Now all we have to do is grab this equation we formed first, and we have to plug these values instead of these functions, and that's going to be the final answer. Now let's go ahead and do that. So first we are going to begin with f of 0, that is 1. So we are going to have 1 plus f prime 0, that is negative 5. Negative 5 over 1 factorial. 1 factorial is just 1, so we don't have to write anything in the denominator. We can keep negative 5 right here, and then we are going to multiply this one by x. And the next value we are going to have f double prime 0, and here we have found out that's 50. 50 divided by 2 factorial. If you expand 2 factorial, that's going to be used 2 times 1. That's still going to be 2. So this is going to be 50 divided by 2, that's going to be 25. 25 x square plus f triple prime 0, that is negative 750, 3 factorial. So negative 750 divided by 3 factorial, 3 times 2. So it's same as 6, right? 3 times 2 is 6. And if you divide this one by 3, it's going to be 250. And negative 250 divided by 2 is going to be negative 125. Now we can go ahead and plug negative 125 instead of this. So this is going to be just negative 125 x cubed, and that's going to be the final answer. Now let's go ahead and draw a box for this one. So this is our final answer, and that's how we do Maclaurin polynomials. I hope you guys find this video helpful. See you next time.